Hello students, hope you are doing well. Today we are going to solve one problem on ANSYS. A rectangular plate of 100 length and 50 width and 0.0 thickness having hole of 30 diameter at center of plate. The plate is made up of isotropic material of structural steel having Poisson's ratio 0.3 and Young's modulus of 200 gigapascal. The one end of the plate is fixed and other end subjected with uniform tensile load of 50 Newton in axial direction. Find the deformation and stresses in plate. Now if you see here, there is rectangular plate. It is 100 by 50 width and it has thickness 0.5 The one end of the plate is fixed and it has circular hole of radius 50 at the center. Now here, what is this 2 Newton per square? So this is the pressure. This is the pressure. Load is 50. So how we calculate the pressure? Pressure is nothing but the force upon area. So force is 50 Newton. And what is area? So width into thickness. So 50 into 0.3. So we get the pressure 2 Newton per square. Now we are going to find out the deformation and stresses in plate. Now we start with the preferences. In preferences we are going to do the structural analysis. So we'll select structural H method, say OK, and preprocessor element type. In element type we add element. So here also we add the element. We have to select the solid element quad 4 nodes 182. Say up OK. Then option. So here this plane have some thickness. So here in element behavior we are going to select plane with thickness. Say OK. Close this. Again we are going to add the real constant. So what is the real constant? So here we are going to add this plane. Okay. So here it is thickness we have to add. So thickness is 0.5. Say OK. Then close this. Then material properties. So here we are going to add the material. So I will select the material model, structural, in that linear, elastic and isotropic material we have taken. So isotropic material, you can see here, isotropic material is 200 gigapascal. So I will say 2E5. We have to convert into Newton per square. So 2E5 and Poisson's ratio is 0.3. Say OK. Then close this. After that we have to do the modeling. Okay, so we have to create the rectangular plate. So I will select the area rectangle by two corners. So one corner is 0, x is 0, y 0. What is width? Width is 100 and what is height? Height is 50. Say apply. OK. Second, we are going to create a circle. We have to prepare the hole inside this. So I will select the hole, solid hole. So what is its center? Center point is this. So I will center is 50 and in y direction it is 25 center. And what is the radius? Radius is 15. Say OK. So this circle is generated. Now next is we have to remove this circle. We have to remove the circle from this rectangular plate. So we are going to do the Boolean operation. So in operate we are going to do the Boolean operation. In subtract, select the area. First select this area. This area become pink color. Say OK. OK. So first area is selected. Second, the second area. Now again this area is selected. So you have to do the next. So it will select this area. So this is our area, second area. OK. OK. Now this is saved. Now once you complete this, once you completed this problem, this Boolean operation, make it save db. So this up to this work is saved. Next is we are going to do the meshing. So here we use the mesh tool. In mesh tool we have to set the area, so I will select here set which area we want to, this area, so it will be okay. So it will ask me element edge length size, so I will say 3, say okay. Similarly, again we are going to do the mesh tool. We have to choose which type of meshing. Either it is a quad element, trigonal element. So I will say quad element mesh. Select this area. Say OK. So once you select this area, the mesh is get applied. Now next is we have to do the loading. So here I will define the load. Here we are going to apply structural, and then in that displacement on nodes. So here with this peak I will seek the peak box. I will select this box here, select the point here. So you can see here all nodes on this corner get selected. Say OK. So it is asking me, so I will say all degrees of freedom. Say OK. Now these nodes are fixed. Next is I want to apply the pressure. So pressure on nodes, I will select these nodes. So if I select single, so it will get single. But of what I will do, I will pick box and I will select this whole nodes. Say apply. So it is asking me. Okay, so pressure is tensile and it is 2 Newton. So minus 2. So apply. Say okay. So here pressure is get applied. So after that, once the load is get applied, we are going for the solution. So in solution there is solve is there and current ls. Okay, so current load steps. So okay, once you press okay, the solution is done. If is there a problem, it will display the message. So close this, and now we are going to see the result. So all the results are seen in the post processor. So in general post processor, here plot result, deform shape. So I will say deform, undeform, both shape I want to see. Say okay. So it will show me the deform and undeform shape. Okay. So if you want just deform shape, mark here deform shape only. Okay. So it will show us deform shape. If you say undeform, deform, undeform edges. Okay. So it will showing this. This is the edge, and when it is get deformed, this will be the shape. Now next is, if you see the nodal solution. In nodal solution we will going to use the stress. We are going to check the stress, volumetric stress. Say okay. Now you can see here this red color shows the maximum stresses are produced, and this blue color it shows the minimum stresses which are produced in this region. Again, if you see the list result, if you see the reaction solution for all items. Okay, now you can see here this reaction. Okay, so these are the nodes on this fx and fy. These are the forces. So reaction forces are coming on these nodes only, because these edges, these nodes are fixed on these edges. Okay, so that's why reaction forces are coming on this edge only. Now again, if you want to see the simulation of this problem, so you can see plot, animate deform and undeformed shape. So I will say deform shape. Here I'm going to do deform and undeformed shape. Okay, so it will show me the deform. This was the rectangular shape and it is going to deform like this. Okay, deform and undeform. This is the circular center, and you can see this is the deformation. So close it. Thank you.